so we're also going to be doing math in here. I think you just did math in the nose. Yeah, okay. We're going to be doing math too. Before we start though, a couple of things. For you guys that are in person, at the end of class, would you mind like folding up the chairs and then setting them up in the hallway against the wall? That would just help with like putting them away and stuff. And then just for like everyone, I want to give like a homework reminder or whatever to make sure you're doing your homework because that's going to be really beneficial in the long run. But other than that, yeah, okay. Other than that, I don't have anything else to say. So we are going to be working on, if you have the math ACT packet that Manoj gave you, it kind of has like the fireworks on the front. We're going to be working on pages 8 and 9. And I think we'll kind of be like, we'll definitely use both pages and we'll probably be like flipping back and forth between them. But we'll go over stuff on the board. So definitely pages 8 and 9. Okay, so we're going to be talking about quadratic functions and then more specifically the quadratic equation. And then we're going to be talking about 2 ways to solve these. So I think it's on top of page 8 in your math packet, the quadratic equation. It says, I'll just write it up here. F of x is equal to ax squared plus bx plus c. So we're going to be talking about 2 ways to solve these. The first is factoring, and the second is using the quadratic formula. The math packet also mentions a couple other things, that these quadratic functions, they form parabolas on a graph, and then talks about, some other things of those. But yeah, so to start off with, if you want to flip to page 9 in your math packet, we're going to talk about factoring these quadratic equations. So on page 9, there's an example up at the top. It says x squared minus 7x plus 12 is equal to 0. And so our goal when we so this is what you should see in the math packet. And so when we're factoring these quadratic equations, our goal is to get them into intercept form, which looks like this. This isn't super important, but this is kind of like the form that we want to get it into so we can find our answers. And so the answers to a quadratic equation, we call them roots, or sometimes you also hear them called like zeros. Or solutions. So on the ACT, you can see like any of those types of terms, and they mean the same thing. They're just going to be the answers to like these types of equations. And so when we do get it in this form, P and Q are our roots, or they're our solutions, or zeros, all of those types of things. And so down in the packet on page 9, at the bottom, it's all the way down to like this form, x minus 4, x minus 3. That's virtually the same as this one, except it doesn't have like an a in front. The constant is maybe 1, and there's no y equals. So our answers to this are 4 and 3. So that was just kind of like vocab. We didn't actually go through it. So we're going to go through one and actually factor it.
What did you call the P and Q?
P and Q, like the terms. Okay, yeah. So we are going to solve a couple. Okay, so here's my first quadratic equation. And then usually by solving these, I use a method called barfing. I don't know if all you have heard of that. But it's M so it stands for multiply, add, rewrite, and factor. So to start off with this one, before I even do like the m multiply, I'm going to rewrite my quadratic equation, and I want to get it into that ax squared plus bx plus c form. So right now, 45 is on the other side of our equation, so I'm going to subtract it over. And then set equal to 0. And then from there, I'm going to start with the marking. So the first step is to multiply A and C. And then I guess this is A, this is B, this is C. Our first step is to multiply A and C. Well, A is the constant in front of X, it's 1, and then C is 45. So to multiply, and I guess I'm going to draw. Okay. Along with the marking, usually I always draw like an X kind of thing. You don't have to, but sometimes it helps. So I'll do like my M, A, R, F. And then up at the top, I'm going to write the number I get when I multiply A and C. So that would be negative 45. And then I want to find two numbers that add to B. And my B is negative 4. So, sorry. I want two numbers that add to B and then multiply to negative 45. So it's kind of like a game or like a trick, but can anyone think of two numbers that multiply to negative 4 and then add to negative 45? Sorry?
9 and 5.
Mm-hmm. Yep, 9 and 5. So, it's actually, and so because we want it to be negative 4, it's going to be negative 9 and positive 5. So then I'm going to do my third step, which is rewriting. And I'll write my two numbers here. Negative 9 and 5 are my two numbers that multiply to negative 45 and add to negative 4. So I'm going to rewrite. So I leave my x squared alone, and what we're rewriting is kind of like that middle term. And instead of negative 4x, I'm going to write negative 9x plus 5x. And then I'm going to leave my c, my last constant, alone. Minus 45 and then equal to 0. And then the last step is the f, which is factor. And so how I do that is I factor by grouping. So I'm going to break those two apart and then factor them like separately. So what can I take out of this for the first one?
X.
Just an x, and then that leaves us with x minus 9. And then out of the second one, what can we take out of that?
5.
Yep. X minus 1. And then you x minus 9. Okay, you should notice that what's inside our parentheses should be the same on both of these. And so what we're left with is x minus 9, and then whatever's on the outside of our parentheses, x plus 5. So from there, we've got our p and q, which are like our roots or solutions. And so remember, we want to set equal to 0. So our answers are actually going to be, or I guess x minus 9 is equal to 0. If I add 9 on both sides, one of my x's is 9, and then x plus 5 equal to 0, I would subtract 5 on both sides. And my other x is equal to negative 5. Okay, did it make sense how we got there?
Mm-hmm.
Yeah. Okay. Anyone have any questions? Alright. So, I'm going to give you guys one to do on your own. So you guys can use the marking method and then factor that. Okay, does anyone have an answer? They just want to yell it out. Yep. Our two solutions are x equals -7 and then x equals -5. So I can. Does anyone have any questions about how we got there? No? Okay. Alright, I'm gonna give you another one, and then this time the constant in front of my a is not gonna be 1, so it'll be a little more difficult to factor, but there's the next one. And then I'll give you a hint, one of the solutions is not a whole number. So you could leave it as a fraction. Okay, we'll start going through this one. Then I want two numbers that multiplied at 24 and then add to -11. So those two numbers are what? -8, -3. So now I'm going to rewrite 2x squared minus 8x minus 3x plus 12 is equal to 0. I'll factor by grouping. I could take a 2x out of here, leaves me with x minus 4. And then I'm going to take a -3 out of this one, and that leaves me with x minus 4 again. So my 2 are x minus 4 and then 2x minus 3. I'll set those equal to 0, and you should get x equals 4 and x equals 3 over 2. Okay. I'm going to give you guys one more of these. Alright, does anyone have an answer for these, or the two solutions for this?
X equals 3, x equals 1/4.
Yep, so the answers were 3 and 1/4. Okay, so that was the factoring method to solve these quadratic equations, and then we could also solve them using something called the quadratic formula, which should be on page 8 of your math packet. Yeah, it's under the part where it says like graph to parabola. But yeah, I'm gonna write it up here. So it's x equals negative b plus or minus squared b squared minus 4ac, and then divide that by 2a. I'm pretty sure they don't give this to you on the ACT, like if you need to use it for a question. So it might be helpful to memorize it. If you just like look at it and memorize it, that's okay. I like have this song memorized, which is how I kind of know what it is without having to like read it off of a page. But it would be helpful to like know this by heart or in your head instead of having to look off of something else. But yeah, so the way that we solve quadratic equations using the quadratic formula is kind of just like plugging them in. So let's say I had x squared plus 3x is equal to 5. Well, first thing is I'm going to get all of my numbers and terms on one side. So I'm going to subtract the 5 over. X squared plus 3x minus 5 is equal to 0. And then before we start plugging in, I'm going to label like my A, B, and C. So remember that first thing we looked at where it was in the form ax squared plus bx plus c, which is at, I think it's at the top of the math packet on page 8, but that's the form of a quadratic equation. So our a is going to be like the constant in front of x squared. And so there's nothing there, so it's technically a 1. Our b is the constant in front of our x, which is 3. And then c is that final constant, which is negative 5. And so now I'm going to plug all of these numbers into my quadratic formula. So I'm going to do it over here. X is equal to negative b, so negative 3 plus or minus square root b squared, so 3 squared, I'm just going to write 9, minus 4 times a is 1, c is negative 5, and then over 2 times a, and then a is just 1, so I'm just going to write 2 there. So this is it, but that's not going to be like an option. You have to keep going, like simplify some more. So I'm going to simplify what's under my square root. Negative 4 times negative 5 is 20, so 9 plus 20 is 29. So I'm going to have negative 3 plus or minus the square root of 29 over 2. And so since this is simplified all the way down, this is likely like an option you'll see, and then that's going to be the correct one. They're probably not going to put it in like a decimal form or anything like that. It's probably going to be something like this. So that would be your answer. Okay, so I'm going to give you guys one to do on your own. And then I'll leave the quadratic formula up there just in case you need it. Okay, so 5x squared is equal to x plus 8. And then for this one, I'd recommend getting everything on one side before you start. Okay, so for this one, your x should be 1 plus or minus the square root of 161 over 10. You guys agree?
Mhm.
Yeah? Okay. So that should be your answer for that one. And then we'll do one more of these. So I want you guys to solve this one using the quadratic formula. Okay, so for this one, if you simplify all the way down, you should get x is equal to 3 plus or minus square root 5. You guys agree?
Oh, yeah.
Yeah. Does anyone want me to go over it?
I was confused by the 3, but you divided by 2, didn't you?
Mm-hmm. Yeah. So there was a 2 on the bottom, and so I simplified down and got 3 plus or minus square root 5.
You just simplified,
Yeah, I simplified the 22. So square root of 20, I changed it into 2 square root 5. And then I canceled out the 2 that was on the bottom. And left with square root 5. Did that make sense, everyone?
Mhm.
Yeah? Okay. Just so I'm confused. Okay, so I guess I didn't actually say this, but another way you can solve quadratic equations is by graphing them in your calculator. So if you guys have your calculator out, let me write an example on the board. So say I had 2x squared minus 7x minus 4. And so using your calculator can like help when you're like maybe short on time, or if you, I guess, forgot like how to solve these, maybe if you can't figure out the correct numbers to factor. So if you have like a calculator like this, I have a TI-84, I don't know, you guys all have something similar? Yeah, so you press the Y equals button in the top left, and then type this whole thing in. 2x squared. The x, if you guys don't know, the x is that button on the right of the alpha button. So type in 2x squared minus 7x minus 4. And then once you're done typing it in, just press graph. And so our two answers or solutions are going to be where that graph crosses the x-axis. And so sometimes you can like look at it, it crosses at an exact number. It should be crossing at 4 and then -1/2. But if you didn't know maybe that it was -1/2, you can press second trace and then press 0, because remember I said they sometimes call these answers 0. So press number 2, which is 0, I guess. And then it'll say left bound, so move the cursor to the left of where you're looking for. Right bound, move it to the right. And then what says guess, try and get like as close as possible to where it's crossing the x-axis. And then it'll tell you the answer. It says x is -0.5. And so that was one of our answers. The other one was +4, which you could have told just by like looking at it.
Mine says error.
says error. Okay, so y equals, and then you graphed it. Oh, okay.
Is my x equal to something?
Says inverse. What's it, the flux? Second step. Okay, I'm not sure what's wrong. I would reset it. I think it was like on the back.
This side.
Oh, take off the case. And then like use your pen and then press it. And I think it'll clear out everything because you typed it incorrectly. And so when you press graph, it should just graph the equation.
I typed it incorrectly? Or?
Yeah, you typed it incorrectly.
Oh, I
so
did.
It was
Oh,
right.
it was
I think
right,
it was just some other setting was off. But yeah, so if you're like in a rush, you can use that method if it's quick for you to solve these quadratic equations. If it's one of the ones where, like, it's one of the ones where when we did the quadratic formula, it was like to the square root of like some really big number. Probably when you graph it, you're gonna get like a decimal out, and that might not be an answer option. So it kind of depends, like, choose wisely when to use this method or like when not to use that method. Is your calculator reset?
Yeah, reset it.
Okay, so try it again and then see me, ask me again at the end if it didn't work. Okay, so now we're gonna talk about, the discriminant of the equation, which is, okay, this is also on page 8 of your math packet, and it has to do with the quadratic formula equation. So remember our quadratic formula was negative b plus or minus the square root of b squared minus 4ac over 2a. The part under the square root, b squared minus 4ac, is something called the discriminant of the equation. And so it says this exactly on page 8 of your math packet, but if our b squared minus 4ac is greater than 0, that means that we have two real roots, or like two real solutions kind of thing. And so if we graphed it, it would look like something like this, where it crosses 2 times, crosses the x-axis twice. If our b squared minus 4ac is less than 0, and that means we have 2 imaginary roots. And so our solutions, if we were like to solve it, our solutions would come out like imaginary, and the parabola wouldn't cross the x-axis at all. And then lastly, if our b squared minus 4ac is equal to 0, that means we have 1 real root, or like 1 real solution, and we'll have a parabola that'll touch, it'll just like touch the x-axis 1 time. So these ones they go pretty quick when you're solving for like the discriminant or like any type of discriminant question. And I've seen a couple of these on the ACT before too. But let's see. So say I have x squared minus 6x plus 10, 0. And then the question is, how many real solutions do you have? Maybe we'll say something like that. So even though it didn't, okay, so the question could be like, how many real solutions are there? Even though it didn't mention the discriminant, we'll know that we need to use it, because that's how we find out if we have 2 real solutions, 2 imaginary solutions, or 1 real solution. So you guys are going to have to find the discriminant, which is, remember, b squared minus 4ac. So you guys want to find like A, B, and C and plug that in, and then tell me what the discriminant is, and then how many real solutions we have. Okay, did anyone get a number for the discriminant? This right here, -4. And so because that's less than 0, that means we have 2 imaginary solutions. And so they could try and trick you, like you might be like, oh, the answer is 2. But they're asking how many real solutions there are. So technically there are 0 real solutions. So kind of watch out for that, but make sure to be answering like what the question is asking.
What's a real solution?
The real solution is when it crossed the x-axis twice, or we would have had like 2 answers.
Okay.
And then the other one, where the discriminant was equal to 0, that's when it just like touched the x-axis.
Crosses it once.
And so then there's just one answer. For this one, when our discriminant is less than 0, we have imaginary solutions, and so it never actually crosses the x-axis, and so there'd be 0 real solutions.
But if it equates out to 0, then it's 1. It crosses once, right? Is that?
Yeah.
That count as still as a real solution?
Yeah, that's just one real solution.
Okay.
And then compared to 2 real solutions. So this one, where it's less than 0, our discriminant was -4. It has 0 real solutions. Okay, so let's try another one. Let's say our quadratic equation is x² minus 6x plus 9. I'll have you guys find the discriminant and then tell me the type of solutions. Okay, so what did someone get for the discriminant?
-8c.
Nope, not quite. Yep, the discriminant is 0. And so what does that mean about the type of solutions? There's just one real solution. Okay. Okay, so we're gonna do one more of these with the discriminant. Okay, so again, same thing, find the discriminant. And then the type of solutions. Okay, did you guys get a discriminant?
4.
Positive 4. And so that means we have,
2.
yep, 2 real solutions. Okay. So that was basically all the content I have. So now I'm going to give you guys just like a couple of quadratic equations. And I'm going to have you guys choose whichever method you want to do to solve them. So you could factor like we talked about. You could also use the quadratic formula. And then if you want to, you can try and graph them in your calculator. But just use any method. I'm going to write 3 up here. Use any method you think is best to solve these. That's the first one. Okay, so solve those 3 using any method of your choosing. Okay, we'll start going over the first one. Before we do it, you guys wanna like let me know which method you use
I did all three.
for this one?
Well, I did that. That one I used the first one. The
The factoring?
quadratic equation.
Oh, okay. You use the quadratic equation. What about you guys?
The first two.
You graphed them?
The first one.
Anyone online? What method do you guys use for this first one?
I factored.
Factor.
Factored too. Same.
Okay. Yeah. For this one, I also factored it. I guess, and then the graphing, you guys know we talked about that. But I'll go through how I would factor it. So first I'm going to get the 12x over on the side with everything else. So 2x squared minus 54 minus, that's out of order. Okay. 2x squared and then the minus 12x minus 54 equal to 0. And then actually I noticed that these all have like could be divided by 2, so I'm going to do that. Just make it easier. And so I get x squared minus 6x minus 27 is equal to 0. And then from there, two numbers that multiply to negative 27 and then on to negative 6 are negative 9 and positive 3. So our answer should be 9 and negative 3 for that one. For number 2, the answers were x equals 4 and then x equals 3. Does anyone have questions about the second one? And then for the third one, I think the most cleanest method would be to use the quadratic formula. So if you do use it, you should get x is equal to negative 9 plus or minus the square root of 33 over 8. Do you guys agree? That one? No. Does that make sense? Yeah? Okay. We still have like 10 minutes left.
How could you
hmm?
how do you know to make sure that was best used with the quadratic?
So if we did get the 3 on this side, so I'll just write plus 3 equals 0. And then we tried to mark it, we need two numbers that multiply to 12 and then add to 9. And so, yeah, can you think of two numbers that multiply to 12 and add to 9? Yeah, no, so it's like hard to factor. So for that one, I wouldn't want to use the factoring method. If we were to graph it, it would be like I said, you'd get like a decimal, because this would get a decimal out. So in order for it to be like the cleanest answer, we'd use the quadratic formula. And so just plug in like the A, B, and C. Yeah, so when you can't factor, I move to this one. If you do notice, maybe there are decimals in the answer choices, then I like go ahead and grab it because that goes a lot quicker. Okay, so with I'm gonna give you guys, I guess with the last like 10 minutes, I'll just give you guys like a couple more practice questions and then we can end early. Let's see. So, here's one. Okay, so do those last two and then we will be done. Okay, so for the first one, your two solutions should be x equals 6, and then x equals negative 2/3. You guys agree with that? Yeah. And then the second one, should be one answer is x equals negative 5/3. Something like that. You have a question?
How did they say a quadratic again, right? What did I, do I have to extend further?
So for the first one?
Yep.
Okay, so. So it was 16 squared.
It's 256.
And then minus 4
One.
times 3 times. Okay, you should get 400 if you do. Did you do 16 squared and then minus 4 times 3 times negative 12?
I probably didn't. Like, I probably did the. Probably
Oh, this part.
unders wrong.
Okay, so you should get 400 under the square root, and then that should simplify to a whole number. And you should.
Okay.
That's,
Got it.
okay. Yeah. So sorry about that, but everyone. Yeah, I don't have anything else for you guys, so you guys are free to go. If you have any questions, you can stick around and ask me. But thank you for coming.